Hello students. Let us go for one more question from this year GATE 2025 question paper. So this question is from EMT, and in this question they say that you have been given a uniformly magnetized cylinder, okay, and they're asking if cylinder is uniformly magnetized, then which of the following options are correct, okay. So if there's a uniform magnetization, okay, so straightforward I can write that my bound current density del cross m will be 0 because there is a no variation, okay. Similarly, if I write the surface current density, that is your m cross n cap, okay. So now m is and k direction, okay, m is given in the k direction, k cap, n cap in the radial direction. So your surface currents will be in the phi cap direction. So this is the same like your solenoid, okay. The currents are flowing on the surface in phi direction. So and for solenoid, B outside is 0, okay. Now if I find here magnetic field, so this is surface current. So they say surface current density on the curved surface is non-zero, so this option is correct. The bound volume current density is 0, so this option is also correct, okay. So B and C is correct. Now if I talk about the magnetic field, okay, inside a uniformly magnetized material, so magnetic field is your H plus M, okay. So there is a no external field H in this question, okay. So and so if I write B, so B will be your mu 0 M, H is 0, okay. This will be inside, this is inside the material, and outside the material B will be 0 because there is no external field, there is no material outside. So outside this is 0, okay. Now the third option number A says the magnetic field at any point outside the cylinder can be expressed as the gradient of a scalar function. So we have to see whether del cross B is 0 or not. If the del cross B is 0, then we can write as a gradient of field. So first of all, if I talk about the H, so H is always depends on what? H depends on your free currents, okay. So here you don't have a free current, so del cross H, del cross magnetic field intensity is 0, okay, whether it is inside or outside, okay. Let us talk about the B. So if I write the B, so B is equal to what? We know Maxwell equation, it is J free, okay. Now you write E del E by del T polarization, okay, or displacement. Now if there is a magnetization, so you can also write one more term, you can add mu 0 del cross M, okay. Now there is a no, if I see outside, okay, outside the cylinder, okay, or even inside there is a J free is 0, time varying field is not there, okay, this is not there, and del cross M is already 0, okay. Del cross M is already because there's no variation in the field, so your del cross B is 0. So del cross B is 0, okay. That means I can write my B. So H I can always write minus del phi M because curl is 0. Del cross B also I can write outside. If I write outside here del cross B, so I can write B also. This is a conservative, it's a curl, so I can always write B as a gradient of A because curl of a vector is 0. That means you can always write it as a some scalar function, gradient of some scalar function, okay, gradient phi. So option A is also correct, okay. Now let us talk about the third option, the surface current density on the flat surfaces. We already talked about these surfaces, we didn't talk about the flat surfaces. So flat surfaces, what will happen? M is in the z cap direction, okay. Now n is also in the same direction, so this will become 0, okay. So the option D, okay, so A is correct, B is correct, C is correct. This is non-zero, but is zero, so option D is correct. So option A, B, C are correct for this question. Okay, hope you understand the solution. Okay, thank you very much.